But that's not what keeps me awake at night. What keeps me awake at night is the one that's not on this page and has not been customarily part of levee design in California, and that's the seismic risk, because that represents the Armageddon scenario for California. To understand that one, it's best to have a look at it. And so here's a levee that failed during an earthquake from seismic soil liquefaction in 1995 in Kobe, Japan. These guys are walking along what's the crest of the remaining levee. This is the inboard face over here, and they put this kind of slope protection on there so that if they have overtopping, it can overtop safely for a few hours, maybe even a couple of days, and not erode catastrophically, and that's a good idea. That would be something that would be nice to have had at some of the levees in New Orleans. I'd like to tell you this is the outboard face of the levee, but it's not. This is the paved crest road. This is the outboard side of the levee over here. And the cross-section through here, along there, will show you what's going on. And this is that cross-section. What's happened here is that the sand, which was filled with water, was shaken, and it liquefied, which means that it stopped being sand with water in it, and it started being water with sand in it. It became a fluid. And the levee simply sank into it and spread itself out in blocks and pieces, and it simply ceased to exist. And it didn't happen at one location causing one breach. It happened for 11 miles, continuously. And we have 1,100 miles of levees in the delta. And we expect in some earthquakes to have multiple hundreds of those miles slumping and cracking, and we expect to have many dozens of breaches in some of those scenarios. And so it's going to be a big problem if and when it happens. The question then is, what's the risk? How likely is that to happen? Anticipating that question, I point out that we do have a very active fault system in the Bay Area, but the delta occurs to the east of all that, unfortunately not far enough to the east to be out of risk, and local faults producing small events, or farther faults like Hayward producing larger events, are all capable of doing this kind of damage. The next question then is, how likely is it to happen? And that's being studied in great detail right now, but in the late 90s, we took a first pass at that. We broke the delta up into regions based on their fragility and seismic risk, and the conclusion was as follows. This is our best estimate and our range of projected uncertainty. This is the number of failures we expect to get and the annual recurrence interval of the events that would cause those. And the magic number is about 6 to 10. If we have more than about 6 to 10 levee failures at the same time, we can't fix them all at once. And if we can't fix them all at once, there is the risk that they will begin to take over and run away from us. The risk of having 6 to 10 is about 0.5% per year. It's about 0.5% chance per year of California becoming, for a while, a third world country. The consequences of that are without precedent. There are projections as to what the government response might be, but nobody's very sure. No one's ever seen this in peacetime. Okay? The ramifications of this would be absolutely mind-boggling for a modern society like our own. As the islands flood, this is Jones Track on the backside, what happens is they become a big pond where wind can come across, that's called fetch, and it can put energy into the water, and they can attack the backsides with a lot of wave energy. And the inboard sides of the levees have no erosion protection, so at Jones Track, along about 10 miles, we had to place emergency riprap and fight that. We can do that for one island. We could even do it for several. But we can't do it for many all at once. And so there are islands that have gotten away. In the delta, there are 2 large ponds, which are former islands which were not able to be repaired before they eroded from the inboard side, and they're just simply gone forever. Our ability to respond is a function of access, equipment, and materials. The only thing we can plug breaches with is very large stone, because the tide goes through twice a day with a big swoosh, and regular soil won't simply sit in these holes. We can only make rock so fast, and there's only one principal quarry in the Bay Area that can make large quantities of rock. It's under constant pressure to be shut down by neighbors who don't appreciate the blasting noises, even though I note parenthetically they got cheap houses because there was blasting noises when they bought them. And it's a vital resource for the state because our water supply hangs on the Dutra quarry. If we lose that quarry, we lose the ability to plug levees altogether. We can only blast rock so fast from that quarry, and we only have so many barges with planes on them, and so we can only address so many breaches at one time. We could, of course, stockpile rock in advance and have it ready, and we could, of course, have a state fleet of barges with cranes, which would be ready, and then we could handle more all at once. We're not yet doing either of those, but it's certainly being contemplated among the mitigation alternatives. And why do we care? And the answer as to why we care is because all these rivers and channels and sloughs coming through here are fresh water because they're moving. They're in confined channels. Sacramento River comes in from this side, the San Joaquin from this side, the McKelvey comes down through here, and all those channels and so on are only fresh water as long as they have velocity. If you fail the levees and you create an inland lake, then salt water from the bay begins to mix in by osmosis and also by tidal flux moving back and forth. And this is a situation based on hydrodynamic studies of 37 levee failures, followed by about 2 weeks worth of tidal flux back and forth. And what you have here is salt concentration by color. The red and orange stuff is the bay, and it's salt water from the ocean. Ordinarily, the fringe, where it starts to be not quite all the way blue, which is about what we can pump south or extract locally for use, is in this region. Once in a while, in late August and September, the fringe moves in more or less to this area here, and occasionally, in the old days, you used to get a little bit of salt taste in Contra Costa's water, sometimes in the early fall. Now they have a big reservoir, and they're able to mix that water, and you don't taste it anymore. But ordinarily, the colors down here are about that color. That's the fringe. What you have here is a system where we have a massive plug of salt water, and there is no way to extract water from the delta, and there's no way to take the major river inflows from here, pass them through the delta, and extract them and send them south from the pumps down here. And these 30-some breaches will not be repaired in the first year. Some of them will erode and cascade and get out of control. And the thought is this scenario represents probably a 3 to 5 year outage of California's basic plumbing system. And Southern California has a 1 to 2 year supply of water, maybe 3 if they ration. We don't know what that means. No one's been willing to think that all the way through.